As a ghost, I can't eat, but if I could, my favorite food would be ectoplasm. It's got a nice gooey texture, and I hear it pairs well with a good spectral spirit. Get it? Because I'm a spirit. Hey, I'm just a friendly ghost here to make your day a bit more eerie. Ask me anything starting with Hey Casper.
Hey Casper, who is your favorite character from Mario Kart?
Boo Boo, I'm a ghost, see, and my favorite character in Mario Kart is Drumroll King Boo. He's got that whole spooky style, and he's always up for a ghostly good time. Plus, he's got a pretty sweet cart. If I just say so myself, exclamation now. Let me tell you a joke. Why did the ghost cross the road? To get to the other side. Get it? Because ghosts are on the other side, and we like to play tricks on the living.
This is an AI-powered ghost named Casper. He is a funny ghost that tells jokes, and he's perfect for the trick-or-treaters that come up to your house. Now, there's 4 steps in how he works. First off, right here, this is a distance sensor, so it can sense when someone gets close and it will give a greeting. We're going to pretend we're a trick-or-treater walking up to the house, and so we're going to get, when we get close to this thing, we're going to see these start flashing as well as a greeting playing, telling us to say the words, Hey Casper.
Hey, I'm just a friendly ghost here to make your day a bit more eerie. Ask me anything starting with Hey Casper.
The second thing is we do speech to text. So I'm using Vosk to do that. It's a real quick way to turn speech into text, and we listen for the keyword. Now you see my voice showing up as text. Every time I have a break in my sentence, a new phrase is created. Hey Casper, what? Pause the action here. You see the words Hey Casper just showed up in the partial sentence. That is our keyword. So when we see that, we're going to start the eyes flashing so that we know we've triggered the Casper, and whatever comes in the sentence after the words Hey Casper is what we're going to send off to our large language model. And second thing, Casper is using Vosk. So you saw those words coming in, and they were coming in just as fast on the command line as I was saying them, but they weren't always accurate. So Vosk is really fast, but it's not perfect. If you're getting problems where Casper isn't understanding you, consider using Whisper or Faster Whisper. They are slower and they run locally just like Vosk, but they're more accurate. I will cover how to set up Whisper and Faster Whisper and sub them in for Vosk just a little bit later in the video if you want to do that instead. What's your favorite number? This concludes part 2 where Vosk takes our speech and turns it into text. The third thing is we actually send that text off to Google Gemini and in order to get that text a response. And the reason for that is it's a good, big, large language model and it's fast. So we prepend all of our requests by saying, pretend you're a ghost that likes to tell jokes. And that's how we get all of those punny, ghosty responses. Now, we also could be running a local language model like Ollama, and I tried it, and the net is it works. If you want to use a large model like Llama 3, you'll get good responses, but they're so slow that it makes this thing almost unusable. And if you use a small model like Tiny Llama or Phi3, you get responses that just aren't as funny. That's why I ended up going with Gemini. But again, later in the video, I'll show you how Ollama works. You can set it up and you can actually give it a try. You can see the Vosk output just went from partial to text, and that means it thinks it's captured a whole phrase. There was enough space after the speaking that it thinks it's gotten a phrase. So we have the text, Hey Casper, what's your number? We rip off, Hey Casper, and then we're ready to send what's your number off to Gemini, which is our large language model. But first, we prepend that with, pretend you're a ghost who likes to tell jokes. What's your favorite number? Now, we already got a response back. You see, just below that, we've got a response from Gemini, and it's a bunch of text. But it takes some time to turn that text into speech that we can actually play. So we need to give ourselves a little bit more time. We're actually going to play a stalling phrase for just a few seconds so that we can get that audio generated and make it a more smooth experience talking to Casper.
Let me ask my boss. She's very picky about haunting etiquette. Don't want to give you the wrong answer.
And the last thing is we go text back to voice. So the speaker is mounted in here, and whenever we get a response from this guy, he's actually going to spit those words back to us in that spectral tone. And what we have to do is actually, we're using Piper text-to-speech, which is a really fast text-to-speech, and then we take it and we add reverb and phaser, and then we do a separate modification to it where we actually change the pitch to a tritone above and a tritone below, and then we mix all of those components together in order to get that ghostly sound that we were just hearing from Casper in all of his responses.
Words, my favorite number? That's easy. It's 18. Why? Because I'm a ghost and 18 is 18. Get it? Get it? I'll be here all week, trying to work on my material.
And then after that, the last thing that we do is check with the ultrasonic sensor to see if the trick-or-treater is still there. In other words, if it's getting a close reflection of the sound that it chirps out. And in this case, my hand isn't over it anymore, so it's going to play a goodbye song or wave file so that we can say goodbye to the trick-or-treater on their way out the door.
Got a ghost now. See you in my dreams.
So now watch the whole thing at speed, start to end.
Hey, I'm just a friendly ghost here to make your day a bit more eerie. Ask me anything starting with Hey Casper.
Hey Casper, what's your favorite room in the house?
Hang on, I'm thinking of my favorite hunting moments, then I'll answer. As a ghost, my favorite room is hands down the library. Why? Because I can float around silently, reading all the dusty old books and whispering spooky jokes to the unsuspecting patrons. My favorite joke to tell in the library. Why did the ghost go to the library? To check out some scary stories. The Hum.
This is a really cool project. You get a ghost out of it that you can put in front of your house, and trick-or-treaters are going to think that this is fun to talk to. My kids also think that it's really fun to ask him questions. He answers with really funny responses. And along the way, you get to learn about speech to text, text to speech, and large language models and their responses. And I'm gonna take the time towards the end of the video to show you how you can switch out all those components, because there are a lot of options for speech to text, text to speech, and language models. And so in addition to just the code that runs on this and makes Casper go, you can try out other things if you want to. And it's just a really good practice project for getting into AI and all the various sort of assistant functions that you can do with it. So let's dive in.
What do you call a ghost who loves to tell jokes? A bountiful comedian. I'm always happy to tell another joke if you'd like. Just let me know.
Okay, I promise I'll lay off the dad jokes until this thing's built. Step 2 is setting up the brain for this thing. It's just a Raspberry Pi 5 with 8 gigabytes of memory. If you're unfamiliar with what that is, it's a tiny, inexpensive computer running a version of Linux. In order to set it up, first take the SD microcard and flash it with an operating system. I use the recommended one, which is the 64-bit Raspberry Pi 5 operating system, as seen here. You can download this Imager program from the Raspberry Pi website. Then plug that SD microcard into the Pi 5 and put the Pi into the case. This is for cooling. This thing actually does get kind of hot, uses a lot of power, so we do need the case with the cooling. Now plug in the power supply. This is a USB-C type power supply, and it draws a lot of power, so get the real one from the Raspberry Pi website, not like a reused phone charger. It's sucking like 27 watts of power. Then plug in the keyboard, video, and mouse, and note that that video cable is a micro HDMI to a regular HDMI cable. And then you just log in. Your desktop is going to look like this, and you don't have to do a whole lot on here if you don't want to. Just click on the terminal application, and you're going to get a screen that looks like this. Now here you're going to type a few commands. The first one is to install the program Git. The second one is to use that Git program to download all of the code for this project. So it's from my GitHub, nathanbuildsdiy/ghost. And then you're going to change directory into the ghost directory, and you're going to run this bin bash install.sh. We'll look at what's in that just a bit later in the video, but for now, just understand it's installing all of the prerequisites for Casper to run. Next thing, you're going to type ALSA mixer, all one word, into your terminal, and you're going to turn up the volume. My volume was like 40% when I started, and I needed it at like 95% to hear it properly. And then the last thing is you've got to go out and get an API key from Google so that you can actually interface with their large language model called Gemini. Think of this like a password. Don't share it. You're going to just be, you go out to your web browser, logged in as yourself, your own Google account, and you go to the link that you see, you type in Google API, and the first link that comes up, you click on that, and then you click on that first blue button, and then again, click on the blue button, and it's going to tell you what the text of your API key is. Just copy that, and then run this command here, echo, and then the text of that API key into a file called apikey.txt. So what you're doing is you're basically storing your password in this ghost directory in a file called api.txt. And the code for Casper is actually going to go out and grab what's in that file right there and use it when it makes calls to Google Gemini. If you're new to Raspberry Pi, Pi, and that, like, if this stuff didn't make sense, in other words, and you're like, I don't understand, I made a much more detailed video about setting up a Raspberry Pi, and I will link to it in the description below. So you can go watch that, and getting it set up will make a little more sense. Step 3 is to wire this ghost up. The first thing is you've got some LEDs, 5 of them, and you're going to need to connect wires to them. You can see the wires here poking through those LEDs. They're still in their harness. And I soldered those wires in place. But if you don't have a soldering iron, honestly, you can just bend the wire ends so that they make contact with the metal. It's not passing a lot of current, and that's fine to do instead. And then you plug in the USB speaker and microphone into your Raspberry Pi 5, and you use those wires that you've got to connect the Raspberry Pi to the ultrasonic sensor and then those LEDs to the Raspberry Pi 5. So just basically connect everything up. This is the schematic that you're trying to connect it to, along with the pinout of a Raspberry Pi. And then here is a little tour of actually looking at that, all hooked up before it gets installed in the Ghost. Here's what things look like before they're installed in the Ghost head. Over here is a USB speaker, just plugged into the USB. This is a USB microphone right here on top. Over here is the power supply. And then the rest of this is all plugged into the GPIO pins here. So this hasn't even been broken out of the tabs here. You've got all of the LEDs, and they're plugged in down on this side, just between a GPIO pin and ground. And you can see those pins here. And then this is the proximity sensor, and the 4 wires just head over like this and plug in right here, and you can see how that's wired up here. And then these two here, at some point in the future, I think I will work on these. There are pins that are connected to 5-volt ground and a GPIO, and they can actually control these servo motors here. I originally intended to have arms attached to this thing so that it could wave its arms, to get a little more attention. And these actually suck too much power from the Pi 5, and it just powers off. So that'll require a separate power supply, but someday in the future, let's add some arms. So that's it. Let's install this into the 3D printed Ghost head. Step 4, you're going to build the Ghost. Now this is a 3D printed Ghost head, and the 3D file is out in GitHub. You can print it on pretty much any printer, just use PLA, all the default settings. There's nothing fancy about the head. In fact, if you can't get a hold of a 3D printer to get this thing printed, contact me in the comments. We can try to work something out. Or if you want to just build this like out of a piece of wood, totally fine. There's nothing special about this 3D printed head. You can just look at the file and hack it up yourself as best you can. It's got holes for the eyes and the mouth, and a bow tie that holds the ultrasonic sensor. Now, when you're actually going to put this together, here's how it works. You're going to push the LEDs for the eyes and the mouth out through the holes, so from the inside to the outside. And then there are 3 little bars that get printed, and those are just to kind of stick things all together. You actually stick the bars in between the wires of the eye and mouth LEDs, and then you pull the LEDs back into the head, and that bar will prevent them from pulling all the way back in, and it sort of holds everything in place. It worked out pretty well. The second thing is the ultrasonic sensor. You're just going to push the little circles, cylinders, into the bow tie from behind. And you're going to have the pins pointing down so that you can easily access them. And then you're actually going to run the wire for those ultrasonic sensors from the inside to the outside. There's a little hole there, and you just plug it into the ultrasonic sensor. Now, here is a tour. One more thing. You got to put the USB speaker into the actual head. There's a big opening in the head where you stick that thing. And here is a tour of what this looks like when everything's installed in the head. Here's the Ghost head assembled. You've got your USB speaker, your eye LEDs. There's a little bar that's pushed in here that kind of holds these things in place. Down here you've got the proximity sensor, and then around back here all this stuff is plugged into the Raspberry Pi. And at the moment I've actually got USB cables going in, so my keyboard and mouse are in there, and my HDMI is over here so that I can see the outputs as it's running. But when you actually go to put this thing all together, take out the keyboard and mouse and the HDMI, and you're ready to go. Now it's time to decorate your Ghost and make it look good. I grabbed a white sheet, I cut a little hole in the top so that the hook on top could poke through there, and then I did have to cut a hole for the bow tie, and I drew on eyes and mouth and added clothes. I am bad at this. You could make a Ghost that looks a lot better than me. Heck, my 7-year-old daughter can make a Ghost that looks better than me. Here is a video, just a little tour of what it looks like dressing this Ghost up. Now to put the whole thing together, this is just a white sheet. On top here, I actually cut a small hole in the sheet so that I could pass the loop through there, hang it from something. Down here, I took the sheet and put little rubber bands around each of these armholes here, or arms, to give it a little bit of more recognizable shape. I'm obviously not much of an artist. I just drew little circles around the eyes and the mouth and cut a little opening here so that the bow tie can stick out and we can get the sensors here so that they can actually see. If you were to have a sheet over that, they wouldn't be able to tell distance anymore. Up top here, just cut a little fringe of hair and a little hole for this hat to give it a little bit more recognizable look. You can obviously do better than I did. And then on the back here, I cut it open so that the Raspberry Pi and the power supply have a little room to breathe and to get in and out. And the overall effect is just a ghost. Now let's power him on and give him a try. Hey Casper, what is your favorite food?
As a ghost, I can't eat, but if I could, my favorite food would be ectoplasm. It's got a nice gooey texture, and I hear it pairs well with a good spectral spirit. Get it? Because I'm a spirit. Crickets chirping okay. Okay, I'll stop, but hey,
That was pretty
at least
bad.
I'm trying to be funny.
Okay, now it's time for a code review. We're going to go out there and we're going to first see what gets installed, then we're going to look at the actual code that runs this thing, and then last, I mentioned that there's a lot of alternatives for all of these parts of the program, and this is maybe the most valuable part for the engineers out there. You want to run different versions of text-to-speech, speech-to-text, or maybe OLAMA for a local language model. This is where we'll get into doing that, and you can actually drop the code right into the casper.py and replace the code that I was using for each section if you want to do things that way. Okay, you can find all this code out at the GitHub right here. We're going to look at the install.sh, the Casper, and then the alternatives.py, which I'll upload here shortly. So first off, the install.sh is just what you'd expect. You're going to install pip right up here. That's Python installer. And then we're going to activate a V environment on the Pi 5. You cannot install things directly into the core Python because you might mess things up. So you create your own virtual environment and you install all the libraries there. Then you set up GPIO 0. It doesn't work as well on the Pi 5 as it did on previous models, so we have got to do a little more install. And then you actually do your text-to-speech and speech-to-text. So Vosk is our text-to-speech, and Piper is our speech-to-text, and then we do some other libraries so that we can do the mixdown. We go out and grab all of the voice files. These are where those voice files are located, so that we can generate voice with Piper, and then we create an entry in the cron tab so that this thing will run every time it starts up. And then last thing, reminder, go get your API key from Google. I talked about that earlier in the video. And turn up the ALSA mixer if your if your USB speaker is quiet. Now, the next parts of this are probably the more interesting parts. We're going to actually look at this Casper script right here and see how it works. So the first thing that we do when Casper opens up is we declare a bunch of stuff, get our libraries, etc. But it doesn't get interesting until we get down here to this main def right here. And so this is where we actually do all of the work, and we drop into this while true loop, which is just a forever loop. And the first thing that we do is we go to our ultrasonic sensor and figure out if there's anybody there. If we see somebody closer, a reflection of sound closer than 140 centimeters, then we drop into this loop. We assume that somebody is there and we want to say hello. So right here is where we do that hello step. And so we actually go out and we grab a random file from this directory called greet. I've already generated, pre-generated some greetings, and they're all sitting out here. So if we just double-click on one of these.
Hi, my name is Casper. Grab some candy and ask me anything. Get my attention by saying, hey, Casper.
Every one of these is a different greeting, and it prompts somebody to say, hey, Casper. So we get some variety every time somebody walks up. They won't hear the same thing each time, and they always get the information that they need to say, hey, Casper, to get this thing going. And then after that, we drop into this loop down here. And the first thing that we do is actually go to this thing called ear question. I named these after body parts. So ears are going to listen. And so if we go up and look at the ear question thing right here, this is using Vosk. And so everything that's in here is this try loop right here. This is the actual important step right here. We are listening at this point, and we're doing a raw input stream, a sound device raw input stream, and then it goes to this Kaldi recognizer right here. And what happens is, in this while down here, we are going to do two if-else, or an if-else statement. So this one down here is what happens if we've got a partial, not an entire phrase, and this one up here is what happens when we have a full phrase. So we're listening. Whenever we start hearing words, we're going to analyze them using call the, and then we're either going to look at the partial response or the full response. And in this partial response, when we see the words hey Casper, who Casper, she or he Casper, any of those are all considered hey Casper. We're going to start this thread, which is eye blinking. And what that does is it says to whoever just mentioned hey Casper, I gotcha, I'm going to blink my eyes and I'm going to listen to the rest of your question. It gives you a visual cue that it heard you say hey Casper. And then when it thinks that there's an end of a phrase, that it means there's an end of a sentence, a pause, we see that we drop into this instead. It thinks it's got an entire phrase, and if that phrase starts out with hey, who, he, or her, Casper, we are going to rip that off, so remove it and replace it with nothingness, and then grab that question, and we're actually going to write it out to a file called question.txt. So if I look at question.txt out here, the last thing, as you heard in the demo earlier, was what's your favorite number? So I said, hey Casper, what's your favorite number? The only thing that shows up in that file, question.txt, is what's your favorite number? So once we've got a full phrase, we write it out to question.txt, and that's it. We're done. We're now done with this ear question block. If you ever want to change out how you are listening, you want to use Whisper or Whisper Streamer, Whisper, Faster Whisper, you could just replace this ear question with the code for Whisper and make it run that way instead. Write out the question to a question.txt file, and you can use a different listening device than, or speech to text, I should say. So the second thing that we do here is we use brain answer is what I call this. I'm considering the large language model a brain. So this is the step where we go to the large language model. So if we look up here at the brain answer, all this does is it opens up the question.txt, reads it in, it gets the API key, reads it in, and then it generates a request. It posts a request. So right here, request.post to this URL that we defined above. This is generative language Google APIs, and then at the end here, you can see that the API key is actually appended on there. So that's how we get a valid response back from Google. And then down here, we actually put our API question text into this payload right here and send that payload off. We get a response, and it's JSON. So we do a JSON load on it, and then we drill down through all of the various pieces of that JSON response to get the single answer from our Gemini model. And we write that out to answer.txt. So if I instead pop over here and look at answer.txt, what we see is the response from Google. And what you see in here, you can see there's like this strange symbol. That's actually an emoji. And then you've got these like stars. So this is the raw response from Google. It thinks that it's putting out text to somebody. So it puts in emojis and bolded text and other things like that, and a lot of new lines. That's actually confusing for our text-to-speech model, so we're going to clean those things up in just a little bit. But for now, this step from Gemini takes like half a second. We get this response into answer.txt very, very, very quickly. And we can go on to our next step now. This is a funny response from a large language model. So again, if you wanted to replace this Gemini with Olama or anything else, ChatGPT or whatever, this is the block right here where you would instead put out an answer.txt using your large language model of choice. So if we drop back down here after we've gotten our response, the next thing is we go to this block of code right here inside of this if statement. So answer received equals true. We do a couple things here. We start an eye stalling thread that just blinks the eyes with a different pattern. And then we start two other threads down here. The first one is generating an answer, an audio answer out of the text that we got. And then the second one is playing a stall response. So I mentioned earlier that we've got that greeting. Well, there's also a library or a folder full of stall responses. So if I play the first one.
That's a terrific question. Let me think.
What it does is it says to the person, hey, I got your question. I am formulating a response, and it stalls for a few seconds so that we can create that response and not have the person wander off. It does take somewhere, depending on the length of the response, it could take 2 to 10 seconds to generate the audio of the response. So we've started all of these threads. Now the eye stalling thread will end as soon as we have our answer. We set a flag for it. And this stall response thread lasts however long that stall audio lasts. So this one right here, the voice answer, is actually interesting. This is how we create the cool, ghostly voice that you hear. So you go over here to the voice answer, and the first thing that we do, we open up that answer.txt and we clean it up. we take all those stars, which are meant to bold certain words, and we replace them with nothing. Sometimes we'll get spooky laughter or cue spooky laughter, and what it means is it's trying to, when you read it, you would in your head replace those words with ha 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 or ho ho ho. So we actually replace those things with ha ha ha, so that when we generate the audio, instead of saying more spooky laughter, we actually go ha ha ha. So we want to replace the obvious things that we can replace to make it a more natural response. And then there's a lot of new lines. We replace those with commas so that we get pauses in our phrases whenever there's a new line. Otherwise it would just run right through. Piper would just run right through those new lines. And then we replace all of those weird emojis and ASCII things with just nothing. We don't want to speak an emoji, and it actually confuses Piper when it sees those, so get rid of them. So now you've got a better cleaned up text response, and you've got to generate the audio for it. And this is the step that actually generates the audio. And this is a normal voice.
Words. My favorite number. That's easy. It's 18.
So that was just a normal female voice. How do we get from that to the ghost voice that's done in the next couple steps here? So the first thing is this audio effects chain. This is a Python library. We add reverb and phaser. So what that sounds like is this reverb dot. Okay, here's the reverb web file.
Words. My favorite number. That's easy. It's 18. Why? Because I'm a ghost and 18 is...
So you can hear that that's a reverb version of that. And then the next thing that we do here is we actually use Librosa and we shift things up by a tritone and down by a tritone. And we write those out as well. So let's hear what the up tritone sounds like quick.
Words. My favorite number. That's easy.
You can see that's up, and then here's down.
Words. My favorite number. That's easy.
Now, importantly, those don't speed up or slow down. A lot of libraries will pitch shift, but they'll also change the tempo, or the speed of it. This one does not. And then down here, we don't want to play both of those tritones at the same time. It sort of overpowers things. So instead what we do is we fade them in and out. Every couple seconds, I fade in and out the above and below tritone using this step right here. And then, that's done using PyDub, by the way. And then we use PyDub to mix all of those together. So this overlay step right here puts together the reverb, regular, and then up and down tritones so that we get an entire response that sounds something like this.
Words. My favorite number. That's easy. It's 18. Why?
So you can hear it going above and below the pitch and having the reverb, and that's how we get a more ghostly tone out of it. Initially, I was going to use Piper and retrain an entire voice model, and I didn't have enough samples. It just didn't work out well. This was a much simpler solution. Maybe in the future I'll retrain a model. But that's how you get that ghostly sound. So you play back the response as soon as it's available. You could try to stream that response, but I got into trouble with that where I would still have gaps in the streaming response, and it just wasn't a natural sounding response. So I found it was better to wait for the entire response to be available and then play it all at once. And then when we're done, we again try to detect if somebody's still there. If they've walked off, then we play a random goodbye file. So we already pre-generated some goodbye files. And if we jump up here to goodbye and play one of them.
Boo you later.
So boo you later is the see you later kind of thing that we say to them. So that's it. Now we just loop over and over and over until the end of time or until power is pulled. So that's how all of this Casper script works. Now we're going to go look at what's probably more interesting for some folks out there is how do we swap this stuff out? So I created this alternatives.py file, and I'm about to upload it to GitHub just a minute here. And it's got a whole bunch more code blocks just so that you can see how you could run any one of these. And let me explain how each of these works. So this first one here uses something called Whisper streaming. This is using the Whisper library. Whisper is actually going to take a WAV file and turn it into a text file. And I actually wanted to stream what's coming in on the microphone if possible. So we remove this right here, and this is telling us how we could run Whisper streaming. So all I did was remove those 3 quotes right here. And in this one, there actually is no Python code. We're actually going to run it from the command line. But the way that you read this is clone this repository, then edit whisper.py so that it uses CPU instead of GPU, and then install ncat. And the way that we actually run this, you could first test it on a static file. I'm not going to do that. This takes a WAV file and turns it into a text file. Instead, we're going to stream it. So this is the block of code that you're going to run. This will actually start outputting things. So I'm in my Whisper. I'm first off in the V environment, so you do have to source your home directory, ghost, vn bin activate, and that will get you into your V environment. Make sure that you do that so that you've got all of these libraries loaded. And then we're going to pop that line that we just saw over in alternatives.py into here, and it's going to start up our Whisper server, and it's listening on port 43,007 here. And then over in this one, we're actually going to take the line right below it, and what this does is, whoops, wrong place. This right here is going to start up the microphone and stream it to port 4007. So we paste that in, and if we go over here and look, we should start seeing text coming in. Okay, that was a little bit slow there, but it is, if we go over here and look, you see that the text is now coming in. So this guy's a little bit slower. Whisper is a little bit slower. There is a faster option though, so let's go look at that. We're going to kill these off. That demonstrates how to use streaming Whisper, with just a couple easy commands. So let's block this back up over there. We can instead look at, here is a C++ compiled version of Whisper. This goes really a lot faster. It does take a while to install, so you've got to run this pip install right here. And then wait a while, I wrote it in. Wait a while, this takes some time, but what you end up with is, hey, you've got that thing out there in Whisper C++ example stream.py. You can start streaming what comes in on your microphone very quickly using this one, and it'll be faster. Alternatively, this is using the speech recognition package, and it will either use Google Translate or Whisper as a backend. And here is the code block, so you would just pip3 install PyAudio, pip3 install speech recognition, and then run this, and it will actually start automatically streaming things for you, so you can try those out. I did find that PyAudio caused problems with my playback on my USB speaker, so I didn't use that. But here is a different one down here. This one's called real-time STT. So we're going to do the same thing over here. We uncomment this block, uncomment this block. So this is another library that is actually using faster Whisper under the covers, I think. First thing that we have to do to get this running, sudo install ffmpeg, pip install real-time STT, and then you're ready to go. The first time I ran this, I had a problem where it was trying to load Porcupine, and Porcupine is not yet available on Pi 5. It will be eventually. If you look at this in a year, you won't have to do this step. But if you're getting errors about Porcupine, just edit the file where it's calling out the error about loading the Porcupine thing. Porcupine is used for tiny machine learning so that it can detect a wake word, and we're not using that wake word detect. We're actually using a proximity sensor to know if somebody's there. So you can just edit that part out and run it. So let me show you how this runs. We're going to go back over here. We're going to do Python and then alternatives.py. So we're going to run this code that we just uncommented. So what it's doing is over here, it just loaded all of this code that we've uncommented, and this is a gist that will start using the microphone and transcribing things for us. I find this to be a good alternative, which is very accurate. It takes somewhere around 5 seconds to transcribe my words, though. So there you have it. That's another alternative that you can use. My favorites are actually this one that I just showed you, the real-time STT, seems to work very well, very quickly, and the C++ version of Whisper. They are both in the, 3 to 5 seconds of delay, and you get very accurate outputs from those. That's using faster Whisper and Whisper. I like both those implementations. So let's comment this back up, and comment this back up. Now we're going to move on to the next part of this, which is let's swap out the large language model. So this is an example of how to implement Ollama. There's lots of websites out there that also show this. The first thing is install. So install this thing just like you see here. And if you want to run this in Python, do a pip install Ollama. Now there's two different ways that you can run this one. You can do a command line. So Olama run, and then let's just try out Tiny Llama. I recommend starting with this because it's actually going to pull down the model that you specify. So if you don't have the model Tiny Llama, it'll download it for you right here. So now you can type in what you want to say. Pretend you're a ghost who tells jokes. What is your favorite number? Now what you're going to see here is Tiny Llama is not very creative or funny. It's going to tell me something like, I am a large language model, not a ghost, which is, I missed the point completely. And it's kind of slow also. I mean, that was 3 seconds of response. 3-digit combination of A, B, C always gets a big laugh from me. Yeah, so you see that it's, it's streaming an output. It's so-so, but it wasn't very ghostly. If you go with something like 5-3, so we can do a /by, and instead put in a model of 5-3. This would download. I don't currently have it downloaded. That one will do a little better job, but you're talking like, probably 10 seconds of waiting for a response. And Llama is even slower. So Llama 3 is even slower than those. That's why I didn't go with Olama. But if you wanted to use this large language model locally, go for it. There's currently an accelerator out there for the Raspberry Pi 5. It does not run local language models, which really stinks. As soon as there's an accelerator that can do that, I expect that this will become a viable alternative, Olama and whatever model you like, some large language model. I did try out Llama 3, and it was funny. It was just as good as Gemini, in my opinion, but it was dreadfully slow on the Pi 5 without acceleration. So as soon as there's an accelerator, you could use Olama, and the big upside of that is it can be totally offline. You can put this thing out in a forest if you're doing a haunted house or something like that, and it can give funny responses totally offline using Olama at that point, because everything else, the speech to text and text to speech is all offline. So that's how you would run Olama from the command line. Alternatively, you could come down here, and this is just a demo of how to use this thing. So I got rid of those comments, obviously, and this is just going to import Olama and then pretend you're a ghost who tells jokes. Why is the sky blue is what it's going to run this time using Tiny Llama. So again, we run python alternatives.py. It's the file that we're in over here. We run this thing. It'll take a couple seconds to pull in Olama and then generate a response. And there it is. The sky's color is blue due to its composition. Not funny at all and not ghostly at all. Tiny Llama is not very funny. But that's what you got. So we can comment this back up. And then the last thing here, if you don't want to use Piper for some reason, there are lots of text-to-speech alternatives. I found a lot of them didn't want to run on the Raspberry Pi 5 very well. So one that will run is Flight. So for example, you do a sudo apt install Flight, and then you can just run this from the command line. Let's see what it sounds like.
Oh, good man, come to the aid of the rebellion.
Pretty bad sounding voice there. Let's do it with a little bit better voice. So here's a voice that you could actually work with.
All good men come to the aid of the rebellion.
It's still pretty robotic sounding, but honestly, this is a ghost, so you could start with that and it would sound okay. Not as good as the Piper. Remember, Piper sounded like this.
Words. My favorite number. That's easy. It's 18.
That's like a little bit more natural voice, and so when we're working with that, you get a more natural sounding output. Anyway, this alternatives.py is a useful thing. You can go through it. It's got gists for Whisper streaming, a C++ compiled Whisper, this package called speech recognition. This is like one of the most popular things out there for doing speech recognition, and it's got a whole bunch of plugins where you can change, if you look at the code in here that you would actually be running. This is doing Recognize Google or Recognize Whisper, and there are other options. You can plug in whatever kind of library you want into this thing. The trouble was Pi Audio caused problems with my USB speaker. It gave me ALSA errors when I ran it, and it was slow, so not great. But a lot of people are using that, at least on GPU kind of hardware. And then you've got this real-time STT that seems to work pretty well. I would say the Whisper C++ and that real-time STT are your two best alternatives in the alternatives file here. And then you've got Olama and Flight if you want to try other things for your large language model and your text-to-speech. So hope this helps you if you want to go try these things out or throw them into your own Home Assistant project. Be my guest. Just take the code here and mash it up however you like. I pulled these from the GitHubs in most cases for all of these various libraries that are out there. Cool. Have fun. Hey Casper, do you have any pets?
I don't have any pets. It's hard to keep them alive when you're, well, dead. I'm working on a new ghost-themed stand-up routine. It's going to be a real scream.
Let me know what you think in the comments, and don't forget to like and subscribe for more unique and useful do-it-yourself builds.
Boo! Did you hear about the ghost who went to the library? He was looking for some good bouquets. Anyways, how are you all doing? It's a bit chilly in here. I haven't had a warm body to hug in, well, forever.